All right, so last talk of the evening. Hope you're all still semi-awake at least. If you are, I'll put you to sleep, don't worry about it. So my talk is called Beyond the Browser, Service Workers and the Application Manifest. So I'll be telling you a little bit about how we can take a normal website and make it available offline to provide a better user experience that hopefully somewhat competes with native. A little bit about me first. My name is Thomas, and I'm a developer here at Frantic. I do a lot of things, but amongst other things, JavaScript, obviously, which is why I'm talking here. I want to sort of begin the talk by assessing the state of the internet today. But before I do that, I just by show of hands would like to know how many of you have heard of service workers? Okay. How many of you have used service workers? Wow. Okay, cool. Well, that's good. So I have something to talk about. So when I mean the state of the internet, obviously I'm not going to talk about the entire internet. I want to talk about native versus not native, and what are the advantages of native, and what do we need to overcome with web technologies in order to provide a better user experience. So there are really two sort of realms. There's the desktop/laptop use, and then there's the mobile use. Native apps on desktops are really not as much a thing for the average user as one would think. This is mainly because they have a reliable network connection, and they're very task-oriented when they are on their main computer. So, for example, 3 out of 5 devices on Amazon.com, like the best-selling laptops, are Chromebooks. Chromebooks can't run any native apps at all, so that kind of goes to show how this is really a thing. But when a user is on their mobile phone, they really rely a lot on native apps to give them a much better user experience, provide content when they're offline, give them push notifications at the right time, and sort of remind them of things as they happen. We couldn't do this in Java with web technologies until now. So enter the service worker. Service workers are a low-level API interface that give us access to push, fetch, and other events like that, which allow us to control the network requests a little bit, meaning that we can make sure that whether a user is online or offline doesn't matter anymore. Now, to show you this kind of in a more practical way, we're going to go through an app. The first thing you see when a user has network access is this. And never mind that it looks like nothing is happening. You can just imagine that this loads, I don't know, kitten pictures or something. So when a user opens the web browser and goes to our site, that's what they get with a network connection. So this is sort of the state we aim to when they're offline. Now, they go outside or sit in a train or go on an airplane, and they have no network connection. So now if they come back to our site, they get this. And this is pretty bad. Native apps would never do that. This is sort of like, let's say, a system error on a native app. And before I continue bashing on native apps, is there any native app developers here? Okay, sorry, I don't really mean it. Sorry? No. So this is what happens when they're offline, and we need to do something about this. It's really bad. It's bad user experience because it's no user experience. And we can do something about it now. So like I said before, we have these service workers now. So, you know, this happens and you go, oh, okay, great, there's this new thing now called a service worker. So I'll just work with that. So what you do is you register a service worker and you let it console log something, hoping that everything magically happens to you. So you refresh the page and still doesn't work. So what's next? Well, like I said, the service worker is a low-level API. That means that it by itself doesn't do anything automatically for you. You have to tell it to do things. So service workers are event-based. They have a bunch of different events, but the first important event we need to look at is the install event. So in the service worker file you made, You specify a list of files that you would like cached, and you specify an install event. What this install event does is, when the browser sees your service worker for the first time, the service worker will see all these files you specified and go to the network, fetch all those files, and read them all into a local cache. We open a new cache here, and we read all the files in it here. So at this point, you think that, oh, cool, so now I've cached everything, should be fine. So user refreshes, and okay, still nothing happens. That's not good. You installed everything, but you're doing nothing with it. So still what happens is that the browser tries to go to the network, there is no network, nothing goes on. So we need to deal with all these elements that we've just collected in some sort of way that provides the offline experience to the user. What we do this in the fetch event. So what we are doing here is we're saying that if a network request comes in, then look if we have it in the cache. If we don't, go to the network. If you can't go to the network, or if we don't have a network, then this promise is going to reject, and we end up here, where we say that if the user tried to navigate somewhere and we didn't have a network, then just give him index.html, which basically gives him this app shell around it. So now, user's still offline, or, well, they went online once to get the service worker, and when they go offline the next time, we get this. This is just like the first slide I had, meaning that everything, the whole app shell, is now available completely offline. But how did this happen? This seems like a little bit weird now. So what the service workers do, when the user makes a request from their phone or any device, without a service worker, the request goes out and it goes to the network. And what happens after here, who knows? With a service worker, the user is on the phone, they make a request, and instead of going straight to the network, we intercept that request. At this point, we have full control over what was requested and also what the network responds with, or what the cache responds with. So through a cache, we say, if you have it, give it from the cache. If not, then let's go to the network. So this allows us, like I said, when the user makes any request, we can completely modify both what he originally requested and also what the network responded with. This gives us really full control over all requests and responses. It also allows us to defer tasks. There's other events in service workers that let us do that. And it also lets us do things when something happens from the network. Let's say a push notification, for example, comes in. So this is kind of where we left off when a user is offline. And this is great, but we can do a bit better than that. If we go to native again, on an actual phone, we would have the address bar up here, and things would look a bit weird because you would still have to go through Chrome. We don't have an app icon, all these things. So if you remember, or it's actually still currently used, you can put a bunch of metadata in your index file. You can specify icons and colors, and then the operating system will try to sort of use these things to provide a nice experience, so a splash screen, add to home screen, these kind of things. Google has also reworked how this metadata is specified. So instead of having all this crap listed in the index.html file, we have now a really nice, clean way to specify that in an external resource. All we do to make that work, in our index file, we reference the manifest, and then we have a bunch of stuff we can put into the manifest. And these things will be used by Android to make the app feel more native. So we set a background color for a splash screen. We set an icon that shows on the home screen, and also when the app loads. We changed the title bar of the browser to be in tune with our application theme, so everything looks better. After that, well, I wanted to get a screenshot of how this looks, but I couldn't, so just take my word for it. It looks really nice. It looks like a native app. Everything is themed. We have splash screens, we have home screen icons on all these things, so it's pretty cool. So we've dealt with the offline experience and the online experience. The real problem here is what some people on the internet call Li-Fi, which is when your phone tells you you have a full connection, but you really don't have any connection. In that case, we need to modify what we did to the service worker earlier a little bit, because otherwise it would just wait for a network response forever, right? This never fails because there is a network. It's just so bad that nothing can come from the network, but we never get here. So this is sort of an online first approach, if you will. Now we're changing things so that it's an offline first approach. What we do is, if the root URL is matched, we give the user this app shell immediately. We don't even check what they wanted. If anything else was requested, we still go to the network, but this basically shows the app shell first, and we can load anything in there with JavaScript later on. But this is now an offline first approach. So we treat the network as a progressive enhancement and not as something that's given. As I said earlier, the service worker has other things besides install and fetch. One of them is sync. So what we can do is we can, when the user is offline, they do a bunch of stuff, and we just tell the service worker to do that thing whenever they have a network again. So we register a sync event, and we listen to that sync event in the service worker. Another thing we can do, and this is the one that everyone gets excited about, so I'm counting on ad blocker blocking push notifications sometime soon. Yeah, we can send push notification to the user. This is something that requires Google Cloud Messaging, GCM API. But basically what you do is you, when you start your service worker, you register, I think this is like, you register this push manager, and in the service worker you listen for the push and you display push notification content as the push message comes in. There's one third thing that we should do now that we can use this technology, which is to educate the user. For the last, well, since forever, people are used to, if they're offline, we can't visit this website, period. There's no way. So we need to sort of change the mindset of that a little bit. So what we'll do is when we first cache the app, we tell the user, hey, from now on, this is available offline. So you can go ahead and check it out on the airplane or wherever. In conjunction with that, as long as we have a manifest.json file, if your user visits your site regularly enough, then Chrome is nice enough, they will display a little banner on the bottom that says, add this to your home screen, you seem to like this. So we sort of get free advertisement in that way. So there's been a lot of talk tonight, and you've gotten a lot of information. Some of it might be new. So now it's time for you to take a deep breath and relax. I'm almost done. You don't have to stay awake for long anymore. I just want to briefly go over still what we've covered now. So with changes to 3 files and less than 50 lines of code, we can take a website to be available offline or to provide a offline experience to a user. And I say not a better one, I say, oops. I say any, because right now we don't do anything. It's just they're left to themselves. The browser can deal with it. We don't care if there's an error. HTTP has to be enforced for all these things to work, which is a good thing. But once it is, we have this low-level API access to all these really cool events, and we can do stuff with them. And nothing happens sort of hidden in the background. You have full control over whatever you do here, which is a really powerful thing. These sort of, well, web apps, when they're written well, they actually perform, well, I don't want to say better than native, because I guess that depends on the quality of both, but they perform really, really good. And the thing is, if you think about it, we really have native beat at the first interaction. Like, if a user comes to our website, they're already there, they want to do stuff. If we have a native app, they will get a banner that, hey, go to the Play Store and get this app. So that's more steps. We don't have that. We are right there. So we should take advantage of that. I don't really want you to think too much about all these specific things, but I kind of want you to think about what you can do with this stuff, and you're getting more power here, so that's a good thing. So I think like a lot of cool things will come from that. And as I promised, I said you were close to the end, so that's all I had to say. If you have any questions about anything, then feel free to ask, and I try to answer them. Yes. Do we have the microphone?
Can you take the mic?
Oh.
Oops. Okay.
Yeah, does it support Phonegap or these kind of things? Does it work there?
I'm not really familiar with what Phonegap does. I think it's these wrappers, right, to run.
Cordova, and yeah, they
Right.
use web use
So,
to actually.
Yeah, it replaces that really. You don't need any of that anymore. You can run the JavaScript code. It will just be in your browser. You don't need any wrapper or anything to make this work.
Okay, thank you.
Yeah, just a second. About best practice of using this offline approach. Obviously now, if somebody deletes temporary files in browser, they lose it, right?
No,
They don't?
no. The service worker stays when they close the browser. When they delete the history, the service worker will stay there. The caches will stay there until, well,
Until you clear the temporary files, right? Or the cookies and everything.
yes. Okay. Well, once you do that, yeah.
Yeah. So, is there some best practice to make it more like an app that would stay? Even, for example, maybe you upgrade your browser, your Chrome gets updated and it deletes all the cache, and so you would lose it. But instead of having it that way, maybe there is some best practice to make it work like almost like native app, whether it's Android or iOS or even desktop, maybe, so that you could have shortcut and a like more safe location where it wouldn't be deleted. Is there something like that? No.
Not that I'm aware of, no. We do need this first visit where the service worker will get all the files, read them in the cache, and from then on out, we are safe. We do have the app icon, and the app icon on the home screen will stay. But when the user then visits the site for the first time again, they would need to be online to fetch all this stuff again.
Yeah.
I don't know what would be a solution for that. Writing to some sort of disk storage, maybe. I don't know if we can do that anytime soon, but not that I'm aware of right now.
Yeah. I've been looking into service workers myself, and of course there's a thing that they don't work on iOS right now because Apple doesn't want to support service workers right now.
Yep.
But another thing that was mentioned right there is storage. Well, this is not really a question, but I've been looking into this myself, and it's really depressing. Like, if you want to store large amounts of data offline, then the mobile quotas are pretty bad in terms like, let's say you want to build something like Spotify, which lets you like cache music tracks offline, and on mobile the quotas can be as restrictive as like 5 megabytes or something,
Right.
which is enough for like 1 or 2 songs at best. And yeah, you pretty much need at least like a Phonegap like wrapper or something in that case if you want like store lots of data offline. So just something to keep in mind.
Yeah, I think that's a great point for if you want to build really serious apps. This sort of the message that I'm trying to bring across, that it's really simple, something you can do really easily to a normal website right now to just display content. And maybe you don't even need the full functionality of the app when you're online, but at least show, let's say, an error page or do something that you own up to that, and that you don't say that, oh, browser, deal with it, kind of thing.
Yeah.
More?
I've not really looked into it recently. Are the Firefox and W3C app manifest formats, are they compatible with the Chrome one, or are they all still a little bit different?
I couldn't tell you, to be honest with you. I've looked into the Chrome one because that's a pretty recent addition. There might still be minor differences, but it's not this craziness anymore in the index file where we have to specify millions of different versions for icons for iOS and so on and so forth.
And practically speaking, does the Service Worker currently work anywhere outside of recent Android?
Latest Chrome, latest Firefox, Opera, yeah, to some extent, and of course not Safari and not IE, but yeah. But oh, sorry, I forgot to mention a little bit, but I showed it in the first slide. But this is progressive enhancement, right? So we make a check for if Service Worker is a navigator. So we can do this today, even though these browsers don't support it. We don't have to wait another 10, 20 years for IE to catch up with anything.
Yeah, there is an older thing called application cache as well, which can support this kind of functionality as well. And I think it's supported on iOS and Internet Explorer and quite a few things. It doesn't have all this like mobile-oriented features like push notifications and stuff like that, but you can do quite a lot with it as well. So if you want to build like something like this with more compatibility, it's also worth looking into. And
spending a lot of time on.
It is. Yeah, I've heard that as well. That it's quite frustrating. Can be quite frustrating to work with, but at the same time, I read this nice blog post from these guys who make an HTML5 game engine about like that Service Worker can also be a bit of pain to work with if you want to like replicate some application cache features. So there is that too.
The thing is that application cache, it's a really high-level API. You write a bunch of words into a file, and then you hope and pray that everything it does in the background works out for you. Yeah. And if it doesn't, then you are left going through a 500-page long specification document and trying to figure out what the hell is going on. And here they've taken the opposite approach of that. Service Worker, they give you nothing for free. You have to do something, but at the same time, that really gives you control to own what you want to do at what instance. You can use console logs, you can use debugger. It's really, really easy to work with compared to AppCache. Any more? Oh, watch out.
All right. So a couple of years ago, there was a guy, I think it was HelsinkiJS or something of the sorts, that he kind of in very great detail told what the differences were with the caches, and they actually came up with some method of compressing the data so that you could add twice as much, because they wanted basically Financial Times to be available offline so that you could actually read the paper offline. So they would just get some data, and whatever they had, they would just kind of render that if you're on an airplane or something. So they didn't really care what they had. They composed the page out of whatever they had. So I can try to look up that talk and maybe tweet it.
Cool. Yeah.
To at HelsinkiJS. All right. I guess.
Any more? Last chance. Okay. Thank you very much.